In this video, we will talk about homework 5's problem 2. So now we're given a function about fx and y as a joint variable function, and could be, but we need some condition to prove it is true. And y, the range of y is larger than 1, and x is in the range of 1 over y and y. So for the first problem, we need to draw how the definition range of x and y like. So we can see that x is bounded by 1 over y and x equals to y. So if we plot them together, for x equals to 1 over y is in this way, and x equals to y is like this way, which horizontally be x and vertically in y. So these two points actually is intersected on point 1, 1, which is when y equals to y and x both equals to 1. And we can see that y larger than 1, so we take the upper range of y. And so based on this plot, we will take this part as the valid, as what we are given for the definition region of x and y. For the second problem, we need to find how to make find the value of a to make fx xy is a valid value, a valid function, a valid density function. So we can see that y is given by the range of 1 to infinite, and x is in the range of 1, is related by y, which is 1 over y to y. And for the x and y, from integral on x and then integral on y. And this one should be the value of, should be 1. And now when we substitute the fxy in this function as, since 1 over a is a constant value, so we can take them outside, and from 1 for y in 1 to infinite, and this one is related to y, so we don't need to finish it when we dealing with x. So it's 1 over y squared here, and find the integral of dx. So it's from 1 over y and 2y over x dx. Take this first, and then integral on y. So this part, after we integrate 1 over x is ln x. And when we find the range, so we have the ln 2 times ln y, and 2 times y squared, and the integral on y, which constant here. We can take the 2 out here is 2 over a, and then become ln y divided by y squared, and the integral on y on 1 to y 1 to infinite on y. And now we can use the chain rule to substitute u as ln y, and then y is equals to e to the power of u. Natural number of y squared is e to the power of eu, and the integral is eu times du. So now this integral, and the range of it will change to become, for y is in 1 to infinite. After we take the ln, we will have u in the range is into 0 to infinite. So it will change to 2 times a, and the integral on 0 to infinite. u times e to the power of negative 2u. So this one is for over y squared, and then times eu du, which is 0 to infinite u e negative u du. And this after integral, we will have negative e negative u from 0 to infinite. And this one is e to the square minus e to the power 1 over e to the power 0, which is 0 minus 1 is equals to 1. And so we have 2 over a times 1 equals to 1, then a equals to 2. For the third and fourth problem, we need to find the fx and fy independently and to check whether they both are valid. So if we would like to find fy, just take the integral of fx because it's related to 1. So it's as from 1 over y to 1 and fx on dx. So then we will discard the value of x, remove the value of x here. And based on we found before, it's y over y squared. When y is in 1 to infinite, and 0 for the otherwise. Then plot is literally based on this way. For the fy, since the integral we already have for fy as we calculated before is equal to 1. So fy is definitely a valid probability density function. Then we need to find the fx. We know that we don't have value for x. Actually, we can have it from 0 to 1, and also some value is after 1, like 1 to infinite. So we discussed them based on these two these two ranges. If we check it on x on 0 to 1, so it is 1 over x to the infinite and over 2y squared x dy, and take the x out. So 2 over x out. Oh yes, since x is in the range of x 0 to 1, so for the y, we meet because y should be larger than equal to y, so x should be so y should be equal to x over x to make it larger, make it very reasonable. So it's equal to it's from x over 1 and to the infinite, and also take the square 1 over square y, and here is 2y. So it is -1 over y from x over y to infinite is equals to 0 minus x, which is x. So here is equals to 2x times x is equals to 1 over 2. And for the second part, for x is larger than y, and here to make it reasonable, so y is equals to x will be helpful. So fx is equals to from x to 0 to infinite, and over 2y squared x, which is the fxy, and the integral on y, which is 2x times x infinite 1 over 2 y squared dy. And then is this part where we'll have the x 1 over x, so here is x squared over 1. And the plot is in here is 1 over 2, and after 1 it will become a function as the 2x over 1. So it's as this the function of x fx. To check this variable, so add these two integrals together, and from 0 to 1, its area is 1 over 2, and plus the after side is 1 over infinite of 1 over 2 x squared dx. Check is fx, is larger fx to check the probability. So here we are together for the reasonable definition region, and here is 1 over 2 plus 1 over 2, which is 1, and so that's this the function of xy is valid.